This isn't a work of fiction. This is the true story of 3I Atlas, an interstellar visitor that didn't just break one rule of astrophysics. It shattered 10 of them. Its journey through our solar system has forced us to confront a question that cuts to the very core of our understanding of the universe, and perhaps our place within it. Are we witnessing an extreme, one-in-a-trillion natural phenomenon? Or have we just been visited by something else entirely? Something we don't yet have a name for. Join me as we retrace the path of this impossible traveler and explore the silence it left behind. Our story, the one that truly brought 3I Atlas out of the realm of abstract mathematics and into sharp, tangible focus, begins with an act of incredible human ingenuity. For 4 years, China's Tianwen-1 orbiter had been dutifully executing its mission, circling Mars, our quiet, red neighbor. Its world-class cameras were designed for a specific purpose: to map static, predictable planetary surfaces under bright, consistent sunlight. Its job was to look down. But in late 2025, it received a new, audacious directive. A directive that was less a command and more a dare. It was to turn away from its home of 4 years, to pivot its sophisticated optics away from the familiar dusty plains of Mars, and aim them out into the black, toward an object 30 million kilometers beyond. That object, a fleeting phantom against the infinite backdrop of space, was 3IITLAS, and it was a target unlike any Tianwen one was ever built to track. Imagine trying to photograph a speeding bullet with a portrait camera. Now imagine that bullet is the size of Manhattan, but darker than freshly laid asphalt and colder than deep space steel. And it's not just moving fast. It's moving with a velocity that borders on the absurd. 58 kilometers per second. That's nearly 130,000 miles per hour. To put that in perspective, 3I Atlas could have circled our entire planet in less than 20 minutes. It was a racing ember, moving across the sky faster than the orbiter's targeting algorithms were ever meant to handle. For weeks, engineers on Earth worked tirelessly, recalibrating the orbiter's systems. Every adjustment was a high-stakes gamble, a delicate dance between precision and catastrophic failure. A fraction of a degree off, one miscalculation in its predicted path, and 3I Atlas would be lost forever, a ghost vanishing back into the interstellar night from which it came. Then the effort paid off. The Chinese National Space Administration released a series of raw, monochrome images. And for the first time, humanity laid its eyes directly on this interstellar visitor. The images showed a faint, ethereal sphere wrapped in a soft, expanding glow. This was the coma of Atlas, its atmosphere of gas and dust, extending for thousands of kilometers into space. These frames were a triumph of human exploration. They were sharper than anything the Hubble Space Telescope could have given us, crisper than the powerful gaze of the James Webb, and more revealing than any ground-based observatory could ever hope to deliver through the distorting veil of Earth's atmosphere. For the first time, this wasn't a hypothesis traced by elegant equations or a blip on a screen. It was real. An object with light, with form, with presence. But as the triumph settled, a deep and profound contradiction began to emerge from those very same images. The halo of 3I Atlas was strangely, almost unnervingly smooth. It was serene. It lacked the jagged jets, the chaotic plumes, and the violent vapor trails that our science predicted. Where physics screamed there should be chaos, the camera found a quiet, almost meditative order. Where the light from our sun should have flared and fractured against an erupting surface, it shimmered evenly, like a single held breath in the vacuum of space. This was the first hint that something was deeply wrong with our understanding. The success of Tianwen-1 didn't just reveal a picture. It revealed a silence, and in that silence, a great mystery began to unfold. As 3I Atlas made its closest approach to the sun, something measurable but invisible occurred. Its path began to deviate from the one that gravity alone dictated. It was moving as if a hidden force, a phantom engine, was gently pushing it. NASA's Jet Propulsion Laboratory, the gold standard for orbital mechanics, confirmed it. 3I Atlas was experiencing non-gravitational acceleration. The data was precise. It was being pushed outward, away from the Sun, and also forward, along its orbital track. When scientists plugged those numbers into the fundamental equations of momentum conservation, they led to one inescapable conclusion. To achieve that push, 3I Atlas had to have shed a colossal amount of its own mass. The calculations were stunning. Nearly 13% of its total mass, equivalent to about 4 billion tons of rock, gas and ice, had been violently expelled into space over just a few days. And here is the heart of the paradox. Physics demands that such a loss would blaze across the sky. It demanded a brilliant, spectacular tale, a cosmic banner announcing its passage. Yet Tianwen-1, the European Space Agency's Mars Express, and every observatory on Earth that could get a look saw nothing. Absolutely nothing. 3I Atlas remained a dim, serene sphere, wrapped in its steady, quiet glow. There was no plume, no fan of dust, no turbulence. The acceleration was real. The thrust was measurable. But the evidence of that thrust, the exhaust, the debris, the tail was gone. It had performed a magic trick on a cosmic scale. It was propulsion without exhaust, a reaction without a residue. For astronomers, this was the first verified contradiction, a motion that had somehow erased its own signature. And in that contradiction, in that profound and impossible silence, 3I Atlas whispered the beginning of its much greater mystery. Think about that for a moment in the context of our own lives. How often are we confronted with the aftermath of a major event, but we never saw the event itself? We see the quiet change in a friend's eyes after a period of struggle, but we weren't there for the internal battle. We see the final outcome of a massive corporate decision, but the messy, chaotic process that led to it remains hidden behind closed doors. 3I Atlas reminds us that the universe's most powerful moments are not always the loudest. Sometimes the most profound changes happen in a deafening silence, leading us to wonder not just asterisk what asterisk happened, but asterisk how asterisk. That initial paradox, the missing tail, was just the opening chapter. As scientists dug deeper into the data, they uncovered not one, but 10 distinct, independent anomalies. Each one, on its own, would have been enough to make 3I Atlas a once-in-a-generation puzzle. But together, they began to paint a picture of an object that didn't just bend the rules of nature. It seemed to exist outside of them. First, let's talk about how it arrived. Imagine our solar system is a flat, spinning vinyl record. The Sun is the hole in the middle, and all the planets Earth, Mars, Jupiter are traveling in tiny grooves on that record surface. This flat plane is called the ecliptic. For billions of years, comets born within our solar system have traveled along this plane because they were spun from the same disk of gas and dust that created everything else here. They belong on the record. But 3I Atlas was born elsewhere, ejected from a completely different star system, countless light years away. It was an interstellar castaway. Statistically, it should have approached our solar system from any random direction in three-dimensional space, from above the record, below it, or at some steep, chaotic angle. Instead, it slipped into our cosmic neighborhood almost perfectly aligned with our ecliptic plane. Its tilt was a mere 5 degrees, so small it was practically flying level with our own planets. The odds of an interstellar object just happening to do that by chance are roughly 1 in 500. It's like throwing a dart from across a stadium and having it land perfectly flat on the edge of a spinning record. But it gets stranger. Not only was it on our plane, it was moving in the opposite direction. It was traveling retrograde, against the flow of all our planets. So now, imagine that dart isn't just on the edge of the record, but it's sliding along the edge, perfectly balanced, against the direction of the spin. This isn't just a curiosity. It's a mathematical contradiction. To travel opposite the planetary flow while staying confined to the same thin disk requires an immense, almost impossible precision. This alignment was the first alarm bell. No natural mechanism easily explains this. Some suggested it might be part of a larger stream of interstellar debris following the Milky Way, its gravitational midplane, but no evidence for such a stream has ever been found. The discovery unsettled the scientific community. The ecliptic is our cosmic foundation. For this alien object to enter on that same plane, perfectly level, but moving in reverse, was like finding a foreign signature written in our own handwriting. Think about the synchronicities in your own life. Those moments of impossible coincidence, where the right person shows up at the exact right time, or a series of unrelated events aligned to create a perfect opportunity. We call it luck or fate. But when you look at the odds, you can't help but wonder if there's a hidden geometry at play, an invisible pattern guiding events. 3I-ATLA's arrival was a cosmic synchronicity of the highest order, a perfect silent alignment that began its defiance against randomness. The second anomaly violated one of the simplest and most reliable laws in cometary physics. Between July and August of 2025, telescopes on Earth recorded something that no natural comet had ever done. A jet of material erupting toward the Sun. Let's be clear. Every rule of thermodynamics, radiation pressure, and solar wind dynamics says this is impossible. Comets are dirty snowballs. When they get close to the Sun, the ice heats up and turns to gas, which expands and escapes, carrying dust with it. This material is then immediately and powerfully pushed away from the Sun by the constant stream of particles and light, forming a long tail that always points away from the Sun. This rule is so absolute that you can tell where the Sun is just by looking at a comet's tail. But 3I Atlas defied this cosmic compass. Its ejected stream didn't retreat from the Sun's overwhelming force. It advanced directly into it. At first, scientists suspected an optical illusion, a trick of geometry called an anti-tail. But that was quickly ruled out. Multiple, independent observatories in different parts of the world confirmed the orientation at the same time. This was real. For a natural jet to point sunward, it would require a rotational spin so extreme that the object would tear itself apart. Even then, the expelled material should have been bent backward by the solar wind almost instantly. Instead, the jet from 3I Atlas held its vector, steady and focused, for nearly 48 hours. It was a sustained act of defiance against the fundamental forces acting upon it. It behaved less like vapor from a random vent and more like controlled thrust from a nozzle. This anomaly resonated on an almost mythic level. It was the image of a lone traveler pushing back against the star itself, a small object refusing to be bullied by the most powerful force in our solar system. In our own lives, we all face overwhelming forces, societal pressure, financial hardship, personal challenges. The path of least resistance is to be pushed back, to let this solar wind of our problems dictate our direction. But this object offers a different lesson. It's a lesson in agency, in finding the strength to push back, to hold your own vector, even when every force in your world is trying to make you retreat. 3I Atlas wasn't just reacting to sunlight, it appeared to be maneuvering through it. Astrophysics teaches us that size and speed generally don't coexist in nature, especially for objects ejected from a star system. Think of it like this. It is relatively easy for a star's gravity to fling small pebbles into interstellar space at high speeds. But to accelerate a massive city-sized object to escape velocity requires a staggering, almost cataclysmic amount of energy. The larger the body, the harder it is to accelerate. 3I Atlas broke that balance completely. Our first interstellar visitor, Oumuamua, was a tiny shard, maybe 100 meters long. The second, 2I Borisov, was a more typical comet, a few hundred meters wide, but 3I ATLA dwarfed them both. With a solid core 5.6 kilometers across, it was over 1,000,000 times more massive than Oumuamua. And yet, it was also the fastest of the three. This combination is a statistical paradox. Models of galactic dynamics simply do not allow for this easily. To accelerate something that massive to 130,000 miles per hour would require an event like a near pass by a neutron star or a black hole or a deliberate act of propulsion. Neither scenario fits comfortably within known probability. Astronomers described it as a statistical rebellion. Every rule of probability said an object like this shouldn't exist. Yet there it was, crossing our solar system like a projectile forged from the impossible. This speaks directly to the perceived limitations we place on ourselves. Society often tells us you can be strong, or you can be fast. You can be analytical, or you can be creative. You can be successful in your career, or you can be a present parent. We are presented with false dichotomies. 3I Atlas was a cosmic reminder that these limits are often arbitrary. It was big asterisk and asterisk fast. It was a heavyweight with the speed of a sprinter. Its very existence is an encouragement to challenge the either-or mentality in our own lives and to embrace the possibility of being both. And the path 3I Atlas took through our solar system didn't just seem precise. It seemed choreographed. It arrived as if it knew when and where our eyes would be. In September 2025, it swept past Mars, close enough for high-resolution imaging at the exact moment when two European Space Agency orbiters were perfectly positioned to observe it. Weeks later, its path curved near Venus, again during an operational window when probes around that planet were active. Finally, it passed the outer reaches of Jupiter's domain, close enough for detection, but far enough to avoid being gravitationally disturbed. Each encounter was geometrically and temporally ideal. But the most theatrical moment was yet to come. During its perihelion, its closest approach to the Sun, when it should have been at its absolute brightest, the Sun aligned directly between Atlas and the Earth. For weeks, every single ground-based telescope on our planet was completely blinded. The object became invisible, lost in the Sun's glare. The odds of an interstellar visitor, by pure chance, passing directly behind the Sun from our specific vantage point, precisely during its peak brightness, to any system designer, this would look like a perfectly optimized reconnaissance mission, a flight path that skims by major observational outposts before using the largest possible blind spot in the system to conceal its most critical phase. This is a profound lesson in perspective. The truth of 3I Atlas was only hidden from one viewpoint, ours. From Mars, from Venus, it was still visible. It reminds us that our perspective is never the only one, and it's often the most limited. When we're faced with a problem or a situation that seems impossible or makes no sense, perhaps we're just standing in our own blind spot. The solution, the truth, might be perfectly clear if we could only change our vantage point, if we could see it through someone else's eyes or from a different place in our own lives. 3I Atlas executed a maneuver that made chance begin to sound like intention. Until this point, the anomalies were about motion and light, how the object behaved. But the fifth anomaly was about what it was asterisk. When astronomers analyzed the light from its coma, using spectral decomposition, they expected the familiar chemical fingerprint of a comet, volatile ices and silicate dust, with iron being the dominant metal. Instead, they found a metallic echo that was completely alien. There was more nickel than iron. In all of cometary science, such a ratio had never been observed. The proportions of elements in our solar system are predictable, written by the chemistry of our Sun's birth. 3I Atlas broke that chemical symmetry completely. Its spectral lines didn't just show a little extra nickel. The ratio was fundamentally reversed. Where nature in our neighborhood favors iron, Atlas favored nickel. Even more astonishing was the abundance of nickel cyanide compounds, detected at levels thousands of times higher than in any known comet. The signal was so strong that data teams at both the European and Japanese space agencies initially flagged it as instrument contamination, but repeated calibrations confirmed it. The readings were real. This composition is so foreign that it forced astrophysicists to wonder what kind of star system could even produce it. But the real shock came when they compared it to materials on Earth. That same nickel-dominant ratio is found in high-performance industrial alloys materials we use for spacecraft heat shields and deep-sea submersibles, chosen specifically for their incredible resistance to stress, corrosion, and thermal decay. The data did not prove it was artificial, but the resemblance was deeply disquieting. If you were to design a probe to survive the violent, unforgiving journey between stars for millions of years, a nickel-based structure would be one of your most logical choices. This was a turning point. This was the first time nature's handwriting looked almost human. This anomaly asks us to consider our own origins. What are we made of? Our physical and emotional composition tells the story of our journey. 3I says composition told a story of a place much harsher than our own, or perhaps a story of deliberate craftsmanship. It challenges us to look at our own core composition, the principles, beliefs, and experiences that have forged us, and ask what story they tell. The sixth anomaly shattered yet another cornerstone of cometary physics. 3I Atlas was almost dry. Spectral analysis revealed that only 4% of its total mass consisted of water ice. For comparison, a typical comet in our solar system is 70 to 80% water. They are, in essence, dirty snowballs. 3I Atlas was closer to a metallic stone wrapped in a thin whisper of frost. This was not a comet in any conventional sense. The first reaction was disbelief. Water is the lifeblood of a comet. It's the volatile material that vaporizes under solar heat, drives the jets of gas and dust, and forms the brilliant tails we see from Earth. If Atlas lacked water, then what was fueling the massive outgassing? What was powering the non-gravitational acceleration? The physics just didn't add up. A body with so little water should have disintegrated under the intense heat that stripped billions of tons from its surface. But it didn't. It remained cohesive. It resisted fragmentation. It acted, in every measurable way, like something built for endurance. This is a powerful metaphor for a different kind of strength. Not the flexible strength of something that bends, but the hardened strength of something that endures. It's about thriving without the resources everyone else deems essential. In our lives, we are told we need certain things to succeed, a certain type of education, specific connections, financial backing. We are told these things are our water. But what happens when we are forced to operate without them? Can we, like a TLAS, find an alternative fuel source? Can we rely on our own internal, hardened structure to propel us forward? 3I Atlas is a testament to resilience, a traveler stripped of all fragility, shaped not for beauty, but for pure, unrelenting persistence. When light from our sun hit the surface of 3I Atlas, it behaved as if it were encountering something profoundly alien. Normally, sunlight scatters off a comet's dusty nucleus in a predictable way, creating a partial polarization. Think of it like polarized sunglasses, which filter light waves that are oscillating in a certain direction. Every comet ever studied has followed the same optical grammar. 3I Atlas broke it completely. Its reflected light showed an extreme *negative* polarization, a signature so rare that no known natural model could reproduce it. Instead of reflecting light in the expected alignment, a TLAS twisted it, bending the polarization backward. To put it in layman's terms, 3I Atlas was bending light the wrong way. This implied a surface far smoother, denser, or more structurally complex than any dusty comet. Hypotheses ranged from metallic microstructures to a coating of plasma-charged dust aligned by magnetic fields, creating a sort of artificial optical filter. But these were just guesses. Nothing in our telescopic archives had ever produced such an effect. 3I Atlas didn't just reflect light, it manipulated it. This is a fascinating metaphor for perception and hidden realities. It speaks to how a surface can fundamentally alter how we perceive something. We encounter this in our own lives, people, institutions, or ideas whose surfaces are designed to project a certain image, to bend the light of our judgment in a specific way. It's a powerful reminder to question our first impressions, to look deeper than the reflected light, and to understand that a surface can conceal a reality that is complex, alien, and operates by a different set of rules. Of all the strange alignments, one stood out for its eerie, historical echo. The trajectory of 3I Atlas, when traced back into deep space, pointed toward the same region of the sky that nearly half a century ago produced the wow signal. The wow signal, recorded on August 15, 1977, is the most famous and unresolved mystery in the history of the search for extraterrestrial intelligence, SETI. It was a powerful, narrowband radio signal that lasted for 72 seconds and was never, ever heard again. For almost 50 years, no one has found its source. Then came 3I Atlas, emerging from a matching celestial corridor, its path intersecting that same sector of interstellar space. The alignment wasn't exact, but its proximity, a mere 9 degrees apart, was close enough to be statistically stunning. The probability of a random interstellar object entering from within that tiny radius of a location already famous for an unexplained radio burst was calculated to be less than 1%. Correlation is not causation, and scientists were careful not to jump to conclusions. But the alignment was a quiet obsession. If the wow signal had been an artificial beacon, then this massive, technologically anomalous object appeared to come from its neighborhood. This connection speaks to the power of patterns and the search for meaning in coincidence. Are some coincidences so profound that they cease to be mere chance? In our own lives, we often experience these echoes, a recurring theme, a familiar challenge, a synchronicity that links our present to a mystery from our past. 3I Atlas didn't broadcast a sound, but in its silent passage, it reignited the echo of a message we once heard, but never understood. A message that still waits, unanswered, in the static between the stars. On the night of October 29, 2025, something extraordinary happened. Data streams from around the world all reported the same unexplainable event. 3I Atlas had suddenly brightened fivefold. The surge was so abrupt, so clean, it seemed less like a natural flare and more like someone flipping a switch. Ordinary comets brighten chaotically as they release gas and dust. The glow is a messy, dusty, yellow-white. But when Atlas flared, its light spectrum shifted toward a cold, metallic blue. The readings resembled ionized plasma emissions, not scattered sunlight. And crucially, no debris cloud was detected. No new vapor signature appeared. The brightening happened without any apparent loss of mass. This broke the heart of comet physics. Energy had increased, but nothing had burned away. The strange blue glow pulsed with a measured steadiness, lasting for 70 days before fading back to normal as suddenly as it had begun. No comet in recorded history had ever maintained such a constant energetic output for so long without disintegrating. Some scientists hypothesized a plasma sheath event, suggesting the object was a colossal capacitor, conducting electricity as it moved through the solar wind. This was an idea bordering on science fiction, yet it fit the data better than anything else. The blue glow was a signal, not a scream. It was communication without words. This speaks to the many ways we express ourselves beyond language. A sudden burst of creativity, a period of intense focus, a moment where our inner energy just seems to radiate outward. What is our blue flare? What is the unique signal we send out to the world that says, I'm here, not with chaos and noise, but with a clean, sustained, and powerful light? And finally, we come back to where we started. The 10th and perhaps most profound anomaly, the missing tail. In every rulebook of celestial mechanics, the tail is the visible proof of a comet's life and death. It's the evidence. Yet when 3I Atlas lost 4 billion tons of material, the sky remained disturbingly, unnervingly blank. Telescopes from Earth to Mars all confirmed the same impossible absence. Where did those 4 billion tons of material go? Was it dispersed as an ultrafine, invisible gas? Was it redirected by some unknown electromagnetic mechanism? Or was this a propulsive event so efficient, so perfectly controlled, that it left no trace? This anomaly wasn't flamboyant like the blue flare or mysterious like the wow alignment. It was an absence. A vacuum where expectation should have been. It was the measurable lack of something that defied both optics and physics. The official summaries were restrained. No visible dust tail corresponding to the recorded acceleration. But behind those words, every scientist knew this was something deeper. It was like watching a ship cross a vast ocean without leaving a single ripple in its wake. Not because the water was unnaturally still, but because the ship had somehow commanded the water to be still. It was the ultimate statement of control. This anomaly has a deep personal resonance. It is about making profound changes in our lives, moving our own orbits without creating chaos and leaving a trail of debris for others to deal with. It's about focused energy, clean breaks, and the immense power of what is asterisk, not asterisk seen. 3I Atlas didn't just break the laws of motion. It broke the visual poetry of comets, and in doing so, it left a silence that was louder and more profound than any cosmic explosion. When all 10 of these anomalies were laid out, the initial reaction across the scientific community was a quiet, professional refusal to jump ahead of the evidence. But as the probabilities were multiplied, the comfort of random chance began to collapse under its own weight. The odds of all 10 of these independent events coexisting in a single object by accident dropped below 1 in 100,000, perhaps even 1 in a million. This wasn't a claim of design. It was a statistical whisper that nature had just presented something bordering on the absurd. Teams around the world ran sophisticated computer simulations, trying to replicate the Atlas pattern. None succeeded. The data held firm. The anomalies were real. And so, the community found itself at a crossroads. For most, the rational stance was simple. Anomalies require more data, not trauma. 3I Atlas was an outlier, an extreme statistical fluke, until proven otherwise. But a few researchers, most notably Avi Loeb of Harvard, began to argue for something else. His argument was never, 3I Atlas is an alien spaceship. His argument was far more important. When a dataset contains multiple, converging, low-probability events, the responsible scientific act is not to reject the data, but to widen the field of hypotheses. We must practice epistemic humility. We must be willing to entertain possibilities that challenge our core assumptions. This principle divided the field. Official reports from NASA and ESA favored exotic but natural explanations. But informally, the conversation was changing. For decades, astrophysics had been built on the assumption that everything in the cosmos could be explained by natural processes, even if we didn't understand them yet. 3I Atlas disrupted that comfort. It wasn't the suggestion of alien design that shook people. It was the humbling realization that our models of reality might be fundamentally too narrow to hold its complexity. This is a journey we all go on in our lives. We build models of how the world works, how relationships should function, what our career path should look like. And then, life presents us with an anomaly, an event, or a person that doesn't fit our model. The comfortable thing to do is to dismiss it, to call it a fluke. The brave thing to do is what science was being forced to do with Atlas, to question the model itself, to accept that our map might not be the territory. When the old maps no longer work, we must find the courage to draw new ones. So, where does that leave us? In the end, there are two primary ways to look at 3I Atlas. The first, and the one favored by most astrophysicists, is also the most conservative. 3I Atlas is natural. An anomaly, yes, but one born from the unthinkable diversity of the cosmos. Our galaxy contains hundreds of billions of stars, each a unique laboratory of chemistry and gravity. Across that immensity, the improbable becomes inevitable. In this view, 3I Atlas is not an artifact, but a geological messenger from a world older and harsher than our own. It's a lesson that our solar system's physics is not the universe's physics. Science has seen this pattern before. Pulsars were first nicknamed LGM1, little green men, before we understood they were spinning neutron stars. Nature is often stranger than our imaginations. This perspective offers a certain comfort. It allows us to keep wonder tethered to reason. And yet, even here, an unease lingers. To explain 10 independent anomalies as separate, stacked coincidences requires an uncomfortable leap of faith in chance itself. The other possibility is, of course, the one that whispers from the edge of our scientific understanding, that the coherence among the anomalies, the nickel alloy composition, the controlled jets, the stealth trajectory, the efficient propulsion, is not a coincidence at all. That it is a sign of structure, of engineering, of intention. This hypothesis is not provable, and it lies outside the current bounds of conventional science. But as Carl Sagan once said, absence of evidence is not evidence of absence. In the end, 3I Atlas came and went without a word. No transmission, no message, only the profound and unsettling trail of questions it left in its wake. It reminded us that the universe does not always reveal itself in clear answers, but in deep, resonant riddles that demand we have the courage to face the unknown. Perhaps we will never know for certain what it was, but its passage has forever changed how we look at the sky, and it has left us with lessons that extend far beyond the stars, into the very heart of our own human experience. Asterisk. First, embrace the anomalies in your own life. Asterisk. The moments, people, and feelings that don't fit your established patterns are not errors to be dismissed. They are signals. They are messengers, just like a TLAS, telling you that your model of reality may need to expand. Investigate them with curiosity, not fear. Asterisk. Second, be willing to question your most fundamental models. Asterisk. The astronomers who studied this object were forced to confront the limits of their own knowledge. We should all cultivate that same humility. The things we believe we know for certain about ourselves, about others, about the world, these are often the very things that hold us back from a deeper understanding. Asterisk. Third, learn to recognize the power of silence. Asterisk. The loudest events are not always the most significant. 3I Atlas' most profound statement was its missing tail, its perfect quietude in the face of a violent event. Look for the quiet changes in your life and in the lives of others. The actions without fanfare. The strength that is demonstrated not with a roar, but with a steady, unwavering presence. Asterisk. And finally, find your sunward jet. Asterisk. Life will present you with overwhelming forces that try to push you along the path of least resistance. But this strange, silent traveler taught us about agency. It taught us that it is possible, even against the greatest forces, to hold your own vector, to push back, and to choose your own direction. The journey of 3I Atla is far from over. It has slipped back into the interstellar dark, but its echo remains. It forced the world of astronomy to look not only outward at the cosmos, but inward at the fragile and beautiful boundary between knowing and wondering. And that is where all true discovery begins. So I want to ask you, which of these 10 anomalies resonates most with you? Have you ever witnessed something in your own life that just didn't add up, that defied all your expectations? And the big question, if you had to choose, what do you believe 3I Atlas was? A 1 in a trillion masterpiece of nature, or a quiet whisper of something more? Let me know your thoughts in the comments below. I'd love to hear your perspective. This story is a powerful reminder that the universe is far stranger, more mysterious, and more magnificent than we can possibly imagine. If you love exploring these deep questions and finding the human connection within the grand tapestry of the cosmos, make sure you subscribe to our channel and hit that notification bell, because there is so much more to wonder about together.